Hey, here we are. It's time again for John Park's workshop. Hello and welcome to the show. Thanks for stopping by. There is a lively discussion about coffee going on over in the Discord. I think it's lively, at least I've been talking about coffee. Andy has tea. Hello. So if you're wondering where the chat is, if you're tuning in over on LinkedIn or on Facebook or somewhere else, a lot of the chat is happening in our Discord. And you can get there by going to adafruit.it/Discord, and you'll get an invite immediately. You'll launch right over into the Discord, and you'll want to head to the live broadcast chat channel. That's where this is going on. So there's Steve. Hey, Steve. There are worms in your coffee. That's weird. Also, we've got our chat over on YouTube. I keep an eye on that one, but it seems like most people are over in our Discord. So come on by if you want to hang out. It's also a good place for a variety of topics, questions about projects, CircuitPython, Arduino, Raspberry Pi stuff, 3D printing, audio, Git, help with projects in general. So head on over to our Discord if you're looking for conversation and advice or to help people out. It's a great place. All right, let's get the show on the road. Synth of all Lars synths. I saw Lars back there somewhere. Oh, there he is. He's just chilling, wearing some goggles. That's good. It's good to be safe, Lars. What else is happening? I'm drinking some delicious coffee. And one thing recommendation I want to get, I can't remember if I mentioned this before, but I get a variety of coffee. I get a new bag of coffee sort of on a regular subscription, but from different roasters around this nation, and it's through a company who doesn't sponsor me or anything. I get nothing from this, but I've been using them for I think 2 years now, and I really like them. It's called crema.co, and I think there are other services like that, but they just aggregate, they kind of curate different roasters, and when you sign up, then you can use their website to pick and say which things you like, profiles of coffees you like, particular roasters, and then you get stuff, you put it up in your queue, and then coffee comes to you. So I don't remember which one this is I'm drinking right here, right now. I think it's from San Diego. I think I got this one outside of that subscription. It's Modern Times from San Diego. Good coffee. All right, enough coffee talk, I guess. What else is happening? We've got our jobs board over at jobs.adafruit.com. So if you are looking for work or if you're looking to hire someone, it's a pretty good place to do it. This is what the site looks like right here. Head to jobs.adafruit.com. You can see there's a few different posts up here in the Help Wanted section. The Available for Hire section is next to there. You can click there and post your own resume or look for individual people to hire. But this is where you can post your job positions. It's all vetted through Lady Ada and Mr. Lady Ada, so it's all good stuff, and there's no cost for anyone involved with it. So it doesn't cost anything to post, it doesn't cost anything to put up your resume, it doesn't cost anything to go and search for jobs through that. So head on over to jobs.adafruit.com to check that out. Also, other thing, I've got a little show on Tuesdays that I know some of you come by, but if you don't, please come on by next week. It's called JP's Product Pick of the Week. I do it Tuesdays at this same time, so it's 1 o'clock Pacific time, 4 o'clock Eastern time in the United States, and Canada, I think. Do you use the same time zones? I should probably know that. And on that show, I go over a new product pick. Sometimes it's something brand spanking new. Sometimes it's something from our archive of cool products that are in the store. And I give you a little demo of it. I go over some of the salient facts and show some videos of when it was first launched. Sometimes take a look at data sheets, coding examples. And I always have a big discount. This week it was a 50% off discount on this really cool little relay board. So when you want to hook up a relay, there's a bunch of little auxiliary stuff that goes along with that, capacitor and a diode to avoid the collapsing magnetic field ruining your day and so on. And this one makes it really easy because you can plug it into a 3-pin JST connector. We call it the stemma connector, not QT, but just stemma. And then control it from any microcontroller pin really easily, up to 250 volts. And I've got a little 1-minute video to give you a taste of it. Check it out. It is the Stemma mini relay breakout board. So I have a CircuitPy here so I can plug in my power, ground, and signal. And then I've got a standard sort of 110 light socket here. For my connection over to the Stemma QT relay board, I have a lamp plug that's plugged in to my AC power, and then I'm using one of these nice Wago connector nuts to connect one line, and the other is going into common, and then my lamp wire is going into the side of this. And I'm initially setting it to false, which means it's not going to trip the relay. If I just simply change this to true and hit save, bam, we have our light bulb going off. So you can see I'm sort of terrifyingly underlit now. It is the Stemma non-latching mini relay breakout board. Hey, you were about to get the bonus one, little repeat. So that was the product pick, super cool one. So come on back next week to see what's next. I've got a cool one actually. I know what it's gonna be. I have some stuff to build over the next few days in preparation because I wanted to demo a few different things with this upcoming one, so come on back. Wago connectors for the win. Yeah, there was a question last week. Wago? Wago? I call it Wago, and they're great. Love those little clicky connectors. What else? All right, hey, how about we do a CircuitPython parsec? That'll be cool. CircuitPython parsec. All right, let's get set up. Here we go. Let me find my coding window. For the CircuitPython parsec today, I wanted to show you how simple it is to set up capacitive touch sense inside of CircuitPython. So this is an example where I have a little CircuitPy here, and I'm going to use one of its pins as a capacitive touch pin, which means I can touch it or get really, really close to it without even touching it, and it'll sense the difference in the capacitive storage potential of me versus the air, and effectively close the circuit for me or touch it to create some sort of an effect inside of the code. So in this example, I just have one pin on here, the RX pin, and when I touch it, you can see it's acting like a button. I just have it turning on a bunch of these LEDs here. I've got a funky, I've got a broken NeoPixel ring here, so ignore these busted ones over here. But that is just the same as any kind of button or switch that you could close, except it doesn't require an additional mechanical part. This is also really effective for when you want to cover something because you don't actually have to make contact with it, so you can use a piece of paper or fabric or something like that and still be able to touch something. So let's take a look at how this works. I'm first going to go into my screen view here. Screen dev, whoops. All right, and yeah, touch. There you can see what's happening in code. I'm importing the board for pin definitions, importing time so I can put a little delay in, importing the touch.io library, and I'm importing NeoPixel. Then I set up a variable called touchPin, which equals touch.io.touchIn, and then the board.rx pin, or whatever pin you're using. Then I have a little bit of NeoPixel set up, and then it's just so simple. Inside of the main loop of the program, I just simply check to see if touchPin value is true. If it is true, then the things inside of this happen. LEDs get filled red, I print the word touch, and then I have a little sort of debounce pause there. Otherwise, it lifts the pins back up to black. And so that's how easy it is to set up a capacitive touch pin inside of CircuitPython. And that is your CircuitPython parsec. CircuitPython parsec. All right, yeah, someone noticed that Lars is encroaching on us. What are you doing over there, Lars? He's just freaking me out. Stay. All right, so let's get on with the build. Last week, I started the build of the arcade controller, remake of the Pianocade, and this is using These great little gizmos here. This is the LED arcade button 1x4. It's a little stemma QT board, so it uses I2C to communicate with your microcontroller, button presses, as well as the LED PWM state. So we can have 4 buttons with 4 LEDs inside of them. So I have 4 of these set up, so I can use up to 16 buttons, which is actually exactly how many I'm using in this build. If you take a look at the workbench here, I've got just a bunch of parts going on, a bunch of stuff here. Oh, this has nothing to do with it, by the way, but I wanted to show you this. Let me jump out of that for a second. This is just cool. I got this at sort of a state sale junk giveaway thing. I don't know what it is, but it's some sort of really nice plastic hemisphere. So probably that's going to go into some sort of project build, maybe at the top of a UFO. I don't know. Give me ideas. What should I use that for? It's pretty cool. I only have one, so it's got to be it's a one of a kind. Unless someone knows where to get those, where that came from. The estate giveaway I got it from was a sculptor and model builder, so maybe it's a form of some kind. I don't know. Let me know in the chat. All right. So yeah. So you saw here. Let me get back to that view. I've got. Last week I had the buttons sort of just held in a little frame. Now I've been going through some iterations of the enclosure to hold all these buttons, some front buttons, joystick, ports and buttons on the back, ports on the side, lots of wiring. And so what I want to do today is just go over some of that iteration process that I've done in designing the enclosure and then just build the thing. So yeah, Garl Gamp 237 Doom says that totally looks like a UFO. Very much like a UFO. In fact, I can put our little LED ring to work there. Let me set that back there. So let's talk. Let me head over to the workbench, and I'll talk about sort of how the build process has been going for this enclosure for the piano-cade or arcade synth controller. Backing up a bit, in case you don't know what I'm talking about, I'll show an example of the inspiration here. This was a chiptune synthesizer and MIDI controller that was built. I think maybe 100 of them were made. And I don't remember the name of the builder who made this. They made one limited run of them, and that was it. They're gorgeous. There were 2 sizes of them, and made out of like a stamped and bent metal enclosure. Really cool. So you can't get that anymore, so I wanted to make my own version of that because I was sad I didn't have one. So that's what I'm working on. I have a Feather M4 inside of it, and the Feather M4 is running the Adafruit fork of the Teensy audio library, which means I can do synthesis right on the board, and it's got stereo output because the M4 has 2 digital to analog converters, I think 12-bit. And that means we can make sounds. We can generate synthesized sounds in it and output over a stereo audio jack. Also can do USB MIDI control and classic MIDI control. So those are all the things that I have on there. I've got the octave plus 1 key for playing notes, holding maybe chords, could be polyphonic. I was doing it with some arpeggios. I've got some ideas for doing these little patterns or riff generation, as Toddbot called it, trying to come up with the right name for it. Little sequences that'll play. And then the joystick allows us to increase and decrease the tempo if it's a sequence or an arpeggio, and increase and decrease the octave for the sounds. I've also got 3 function buttons on the front, which I've played around with using for things like changing the waveforms, could change the patch up, do a lot of changes to the audio patch. Other things, who knows, change the functions of some buttons. So, but I wanted to focus today on the physical build of it. So let me head over to the workbench here and let's get into it. So let's shift over here and pour a little more coffee. And excuse the mess, just because I've been deep in the build here. I've got stuff everywhere. Here's how the iterations of this have gone. I started with designing inside of Rhino. I took some measurements, and then inside of Rhino CAD program, I designed the, drafted out the case in 3D, extracted 2D curves from that, and then I've been laser cutting the cases. So first version was just kind of the minimum viable thing. Can fit the buttons in there, can fit a joystick. These little joysticks, by the way, I think there's like $15 in the Adafruit store. We have them in stock. These have 4 limit switches in them, little clicky switches, and that's how most arcade joysticks work. So that fits up under here without that on there. And then it screws in place. You screw that little knob back on it, and there's our joystick. So that's sort of version 1 top. The base of it, you can see I've got a lot of stuff to hold, and I also need space for the wires. So this is about as short as I could make it because of the constraints of fitting all that wiring in there. So my per button pair of cables, so there's 4 conductors per button, 2 for the switch, 2 for the LED, go into these arcade stemma QT boards, and I've got 4 of them chained together on the I2C bus, so they have 4 unique addresses. I think it's 3A, 3B, 3C, and 3D, and you can adjust those addresses by cutting a little jumper. There's 4 jumpers you can cut in different patterns to get that set of sequential addresses. And then for the brains of it, I was using originally a 4, the quadrupler for the feather. Allows us to put a feather and a couple of feather wings kind of on a flat plane, which is kind of nicer than a big chunky stack in this case for this design. Turns out I only need 3, so you'll see I've revised that. Here is, so I'll need to pluck those parts out. Here is, after I put that together, here's the front, here's the back with holes for the MIDI, and then there's a couple of side pieces that look similar to that. I think I might not even have them here. I learned some things after putting this together. I was, for some reason, intent on not doing some tab and slot construction. I was going to try to glue this up, put some braces, and I decided that's too much of a pain. With laser cut stuff, you kind of have to accept that the real strength of it is the precision of these types of little finger joints and T-slots. So I found that this was just falling apart too much and not worth the effort. So I also wanted to have a slightly cooler looking shape to the top and bottom of it, and you can see here my next revision was in medium density fiberboard. MDF is it's a little faster to cut than the acrylic, and it's a lot cheaper, so I got some 1/8 inch or 3 millimeter roughly medium density fiberboard and started my revised design cutting it out on this. So you can see now I've got a little bit of a trapezoidal sort of shape here. I don't know what to call that, but a little taper. Somewhat inspired by, in fact, the Pie-Maroni Piecade. They have an arcade cabinet that has acrylic and MDF, and they have kind of a nice tapery shape to it, or I don't know what to call that, diamondy shape? Hexagonal, barely hexagonal. With the sides still being flat, so we just have a little bit of an overhang, as you can see here. Flip that over. So there's, no, there, like that. Oh, I moved it, did I? No, yeah, there it is. So you can see there we have that little shape there, so we don't see the sides as clearly. They get hidden a little bit. And I have a little bit of overhang, I think, on the front and back of it as well. So after putting that together, things were good. I just made a couple small revisions to some hole placement and realized that I wanted to mount my hardware up on little 6 millimeter standoffs. And so since those are up a little higher, I needed to adjust these holes here to fit. And you can see on the MDF, you can also just pencil in some stuff. Power reset, MIDI out, MIDI in, audio out, and USB for power and programming. So that's the MDF version, and once I made a couple small revisions to that, I cut out the acrylic, and I'm using also 3 millimeters. So that means I don't have to change any of these measurements. So 3 millimeter thick acrylic in some cool different colors. So what I'll do, that's an old version of that. I'm going to get these out of here to avoid confusion. Is we're going to pull some things apart and we're going to assemble the acrylic version. And for the acrylic, I decided to go with some different colors for different parts of it. A bit of an homage to colors of the Nintendo Entertainment System. So I like that. It looks cool, cool colors. By the way, the main way that this is held together is with these 80 millimeter long M4 screws with little hex head, cap heads at the top and a nut at the bottom, and then the tabs that hold things structurally. So I have 6 of those around here, and then I have the 4 screws for the joystick. So let's see how all that goes together. And one thing I want to do, I just want to pop up the chat window so maybe I can see that while I'm over here working, if there are any questions. Mike P. had a question, I think, from the CircuitPython parsec, if any pin can be that or if it has to be a cap touch pin. It has to be a cap touch pin that the chip has on it that's been broken out to some trace that we can touch. If you look at the spec sheet on different microcontrollers like the QT-Py, I can't remember if this was the M0 or the RP2040, it'll tell you which pins have capacitive touch. All right, so let's try to get semi-organized here. Let's start off with the base here. So as you can see, I've got 4 nylon M2.5 screws here with nuts that go through the base. And I'm going to put some feet on here at the bottom of it, some little rubber bumper feet so that things don't skate around on the little nuts there. So we'll pop that off. And now we're done with this. One fun thing about the MDF is it's laser cut, it's wood, it has sort of charred edges, and so you get black sort of soot on your hands, which I really don't want to get onto the acrylic. I have some textured light gray acrylic for the top that I don't want to mess up, so I'll try to keep my hands clean if possible. So here, let's take a look at the build on the hardware here. So I've got everything screwed down now, so that way we can use the MIDI jacks without worrying about things falling off. So this is a feather wing that's in the feather tripler. This is a feather proto feather wing, onto which I've added the I2C breakout, little SparkFun I2C quick stemma QT breakout there. Then I have a couple of JST socket pin headers here that I've got for 2 of the buttons that go on the back for the reset and the power that's on the enable pin. Then I have a RC circuit, so a resistor and a capacitor per audio channel, and those go to pin A0 and A1 on the feather, and then out to this 3.5 millimeter audio jack, so stereo ground, 2 lines of audio and ground. And then I've got the feather M4 there. This is the wiring for ground and 4 of the GPIO pins which plug into the joystick. So the joystick, actually, when you get one of these, it comes with a little wiring harness. You just kind of got to figure out which switches mean what, but black is ground, the other ones are the switches, and then in software you can decide which direction means what for that. That's actually one of the only wires that I've hardwired onto something. I originally had a little header. I think last week when I showed this, I had a little header I could plug into, but I realized that was unnecessary and taking up more room than I wanted, so I soldered that down there. So that's my little brain of that build. So I'm going to set this here for a second, and then let's take a look at the some of the laser cut acrylic that we're going to be using. This is the base here. Focus for you. And so into this we're going to have the board that I just pulled out here. There's the 6 larger screws are going to be for holding this together with the 80 millimeter M4s. And then the rest of these are for the stemma QT boards. And by the way, one nice thing with these is they are the same footprint as the other stemma QT stuff. So this is what one of the boards looks like on its own. This pattern spacing is the same as our slider. That's a potentiometer with 4 LEDs underneath it, neopixels, and the 4-button keypad one. So once you get that spacing, you can use that all over the place. Now again, these have I need some clearance here because these have their stemma QT quick connectors on the bottom. So again, I'm going to use these little, this is from the 2.5 millimeter M2.5 nylon screw set. And I'll have to see, I have a few others and I'll be digging some out of the other because I'm running low on, these are the ones that I'm using at the bottom. They're a little 6 millimeter standoff, goes in the bottom, and then you can screw stuff down into them. So that's how these 4 are going to be in here. And it's kind of nice to use all 4 holes. You could do it with 2, but it gets a little wiggly when you're plugging and unplugging. So let's steal these 4 off of here. And the arrangement that I did here was just to try to kind of keep them, oh, did I get that off? That's not quite exact, is it? Did that change? Did I fix that? No? Looks right. So these are all daisy chained together with stemma QT cables, and they go in a pretty specific order that I don't want to forget, so I'm going to leave it wired this way. I didn't mark them on the top side, but that I can show you the jumpers on the bottom or how these are differentiated. So let's go ahead. Now in this prototype build, I just used 2 of the screws. Boy, I wish I had my iPad over here. I guess I can open up Discord on my phone, can't I? Why haven't I thought of that before? Let's see what happens. And, well, that's going to make life easier. Sure. Okay, so let's see. Okay, Ron says, solution for laser soot. Wash the wood edges with an orange pumice soap like Gojo. Hey, that is a great tip. Thank you. I've never heard that or tried that. That's excellent. For those of you who don't know, Okeiron is a very proficient designer for lots of things, including laser cut enclosures, under his Denki Auto brand. Look that up, DENKIOTO, and you'll find cool synthesizer gear with very lovely laser cut enclosures. Dexter Starboard uses graphite to short the address jumper, so that's interesting. Some of our jumpers need to be shorted. Some of our jumpers need to be cut. This is one where they're all cut, and you can just use a hobby knife or other blade to cut it. I don't know if you'll be able to see it on here that well, but I'll zoom all the way in. So you'll see this is the set of jumper pads. There's 4 pairs, and they start off on this board connected, and there's a tiny trace that you cut between them. So I've cut the A0 trace on this one, which means I've added 1 to the I2C address on this board, so this one becomes 0x3b. The uncut one here is 0x3a, and then you do the sort of binary math of the other ones to get up to what you want. Okay, so let's now remove all of these. Zoom out. I don't have a cooking show version of this today, so we're just going to build the whole thing. We'll see how quickly I can do it, how much time we have. We have about a half hour. That seems just about right, I think, to assemble this. I love doing laser cut stuff for this type of a project. It's fast, sturdy, fairly sturdy, and you can do fairly large stuff quickly compared to doing it all 3D printed. You could also do some parts of this 3D printed, some laser cut. I know some people don't have access to laser cutters, plans for this you could, of course, use for making a stencil and hand cutting stuff, sending it off to a service bureau to be done on a mill or a laser cutter. So there's a few ways that you can replicate that. I will leave those. I don't need those. Those are just screws, not standoffs. So I'm going to leave those there. All right. One downside of acrylic is it's very, very staticky, so it loves to pick up little bits of dust and things. Okay, so we will now start adding in these 6mm headers, and we'll find out. You know what, actually? Since it'll be faster for me to build this with 2 and not 4 of these, and that way I won't run out. I think I have others, but I think, despite what I said before, for now I'll do this with, oh, why is my phone dinging? Turn that down. So I'm going to do these again. I'll redo this build to do some photography, so I don't mind doing it partway this time, and then I'll be rebuilding it again. So we'll repeat this sin of just using pairs of standoffs. By the way, these little nuts that we have in the nylon M2.5 and nylon M3 hardware sets in the Adafruit store, one thing about them is they actually have one side of the nut with a little bit of a chamfer as it heads into the screw, which is the easier one to thread into. And then there's a flat side that's not quite as easy to thread into, but if you have very, very tight clearances on things, like you only have just a little bit of, like a millimeter of screw thread to get into a nut, you can usually flip it over to that side and catch it quicker. The threading gets caught quicker. I don't know why they're built that way, but they are. And in a lot of cases, it doesn't matter which side you do, but if you're finding it hard to get a thread started on them, sometimes flip it over. Okay, so that's my 1, 2, 3, 4 of the cutie boards there, and let's go ahead and put those on. I think, by the way, while I'm here, I may go to one wire. We could probably go to shorter wires on all these. I just don't have. I don't think I have them right here. Let's see, but I do. Yeah, so we've got these little. What are these? 50mm. We've got these little 50mm ones. These probably would work instead, which is nice to use shorter wiring. This one here on this end I made pretty darn long, so I'm going to switch that out for a 100mm instead of a 200mm. I think that'll still reach the featherboard here where we need it to. So that'll go like so. And like so. Sure. I think that's okay. It's a little tight, but I think that's okay. Careful with these, they can only go in one way. And after you've used these for a while, you'll get used to the fact that that one way is with the yellow, which is the clock line, wire all the way to the right. It's the easy one to see. So with the orientation that we put these on our boards, usually the yellow is on the right. How's that fit? Yeah, that's pretty good. I think that's a little better. I like that. Okay, and then I'm using the shortest, these are probably, I don't know, 3mm screws in our set. I don't use autofocus on this one, even though it has a pretty good autofocus for humans. But for objects like this, it gets confused by high contrast, busy stuff, which you find all over our circuit boards. So I use manual focus a lot of the time here. So again, if I had a bunch of those little short I would switch them out, but I don't know if I have enough of them right here. Nope. So probably I will opt for those when I do the full build. This is the ones I'm talking about here. And by the way, these are a pain to put in once they're screwed down. So let's see, will that one fit? It probably will, but I don't think it's worth it in this case. So I'll leave it be. Downside of these nylon, Todd says in the chat that I should put googly eyes on my circuit boards so that the autofocus will work. That's a good idea. It's a brilliant idea. All right. Yeah, downside of the nylon screws is that you can't just put them on the end of your magnetic tipped screwdriver and hold on to them because they're nylon. See, look at this. It's done in half the time since we only used 2 hardware standoffs. All right, last of these. And as I had mentioned last week when I was showing how to wire up these buttons, the color coding helps a lot. Having things plug in on both ends helps a lot, because once you get to actually putting stuff together, sometimes you find it's painful to come in from one direction or another. So having it as modular and accessible as we can get away with is a big help. Worth the little extra effort to make that work. Andy Calloway with the big googly eyes in the chat. Okay, so I'm going to go ahead and screw in place. Oh, look at that, all the dust. It's gross sawdust and other things it's picking up. So I'll screw in place the feather tripler board, all those parts there. Close. I do have a little socket set somewhere that's small enough for these. It does make life easier for screwing them on, but I don't have it right in front of me, so I will do it by hand. The kind of last move with something like that usually is Loctite or a similar thread locker to prevent things from shaking apart. So that's on there pretty nicely now, and what you can see is that I've got the orientation here allows me to have MIDI plugs on the back side of this and the USB and audio on this side of it. So that and that is where those kind of main access ports are going to be. All right, so let's build up the sides on here. So for the sides, I decided to go with some black acrylic, and with any luck, we'll get some neat peels here. This is freshly bought acrylic. Usually that means it peels nicely. When you have acrylic, plexiglass, perspex, whatever you want to call it, when you have that laying around a long time, these can become a nightmare to remove. Oh, I didn't know this was textured. Or I did and forgot. Yeah, how about that? Ah, that means that I probably have a random chance that I cut some of this the way I wanted to. Look, I love that. I'm never happy with the glossy, fingerprint-covered, shiny side. This has a beautiful textured side. So, which side was that? I think that was on the white side. The white paper side up. Okay, that means this one is wrong. No, this one's right. Oh, good. So for this one, the orientation doesn't matter. This one's symmetrical in all ways. This one here, I had to set the plexiglass on the laser cutter in one orientation or the other, and I just happened to choose right. I didn't realize. So that means I get this nice textured side aligned properly right? With, oh no, wrong. I'm wrong. Okay, it's going to be the bad side. All right, I'm going to recut that little piece though, because I have placements there that matter. How about that? So by the way, again, this is an endorsement for a place that doesn't pay me or give me a discount or know that I'm even talking about them. I just like them. I've used them for many years. They're called Delvie Plastics, D-E-L-V-I-E. And they have a good selection of plastics for laser cutting. That's kind of the main focus. Okay, well that's a really exciting that I forgot that I got cool textured, but for this build today, it's not going to be the textured side. It's going to be on this side out, and textures on the inside. For this piece, I'll put this one texture side out just to remind myself that that matters. And let's see how I did on these. This one doesn't matter. This one's pretty. These are just buttons that are kind of free floating in space, so I can't get that one wrong. And the other, I think the other one I got maybe didn't get as lucky. Let's see. I wish I had a close-up mic for peeling sounds. Let's do this. Ooh. Look at that. That's really handsome. Maybe I did that intentionally, but I really don't remember. Oh yeah, that's gorgeous. So that piece will go right here, and this is going to have arcade buttons in it. Whoops. Do that so you can see. So that's going to go right there. Let's peel off the back side. You can usually leave this paper on while you're cutting the plastic. Opinions vary on that. Some stuff you don't, like non-paper plastic, I would usually remove, but it just kind of helps it not mess up the. So that's going to go there like that. And like that. By the way, things are a little wobbly because I don't have feet on the bottom yet, and so this is resting on some of those hex nuts on the bottom the way I have it right now. I should probably put down some spacers. Let's peel off the back and put that in place. And did I get lucky on this one? This one matters. This is the height of the MIDI jacks there very specifically, and it's not centered. I think I got lucky and cut it with the textured side up. My phone fell asleep. Let me wake it up there. Frosted matte plexi will usually have a white paper backing on the matte side, says Steve. Thank you. That is good to know. DB9 Dreamer says, so I can't get that one wrong. Famous last words. Exactly. Yeah, there's always a way. I actually made one adjustment to this file right as I was sending it to my laser, and I bumped something a little bit, so one hole didn't line up, and I just had to use a small needle file to make a screw hole fit. So this should, let's see, try to get this held together enough. This all, by the way, in the end is held together by there being a top also with tabs. So it's very delicate right now before it actually has a top on it. But that there, did I get that right? It looks right. It's a little wibbly wobbly. All right, so those, we now know how those are going. I'm going to place them outside here. And now we can start adding some parts. So this is an easy one to do. This is function buttons in the front. And my little color coding, if you remember there, I have button or switch 1, 2, 3, 4 on these boards. They're labeled as such. And I have yellow, red, green, blue as my color order. These 3 are the last 3, so these just start on red, red, green, blue. And put them in like this. Then, by the way, if you like peeling stuff, this is a fun project because every one of these arcade buttons also comes with a little peely plastic on the front of it that we'll get rid of at the end. Function buttons in the front and party in the back. It is a mullet. All right. So these, there are a couple different kinds of arcade button fixtures. These are really deep. As you can see, they could go into like an inch of MDF on an arcade cabinet easily. Some of them just snap into place. These ones have a little threaded collar here, which you just tighten up like so. There we go. That's the little plastic you'll peel off of there. And now these will go into, I guess I can start, yeah, we can go ahead and start plugging them. So for this section, this is the one I didn't label the color of is the, let me push that connector in the rest of the way, is the switch. I only bothered with the color coding on the LED side of it. Once these connectors snap into place, they're hard to pull back out, so I waited until the end on those. Okay, so this is switch on this top and LED on this bottom here. So you don't want to get those wrong or you'll be confusing the microcontroller as it tries to read a diode, an LED, as a digital pin. Okay, next one. You can see here, this is where I say having the 4 buttons would be nice. The 4 rather standoffs would be nice. And LED, switch. Okay. These may have a little bit of a curl to them because of I had it previously in the other case. So that's how those are going to be arranged in there, like so. So let's deal with the back panel here. I just want to double check that that's the right height for that MIDI ports. Yeah, that's right. Again, you can see we're picking up some sawdust, unfortunately, on there. So for this one, I have a couple switches here that are going to be my reset for the microcontroller, which is really helpful when you're programming it. Double-click to put it into bootloader mode. And that's a on-off. Click, click. This one's momentary. So just a mini version, basically, of what the arcade button is like. And that's the other thing, by the way, that if I do any cutting of panels, it'll be to add some text. These are lighted buttons that I decided not to bother with the lights on, by the way. So these are just, this will not tell you the way I've built it. If you want to, I'm going to put out a guide on this. If you want to build it and you want to get a little, go a little further, you can add there's a pair there of posts for the LED. Also on this one, I might tighten this up. You might be able to see I cut an irregular shape. It's a flatted circle, and that's what the shaft on these, just these buttons, not the arcade ones, but these ones are, because they have a little square bezel around them, you kind of don't want them tilting. I didn't do a perfect job. You can see there's a little bit of wiggle there, so I need to get that just a little tighter on there, that flatted circle part, so that those can't wiggle. Again, that's totally unnecessary, just if you're trying to be super precise about it. If you're cutting this by hand with hand tools, you probably won't be going for that kind of precision. I can't, at least. I'm not good enough. But with something that's like a CNC of some kind of laser, then you can. And these are just holes for the MIDI, so that one's done there. And then these will plug in. Let me bring this closer. To put a mark, a colored mark that has rubbed off. Let's see, that one is enable, and that's reset. I just remember that. I didn't mark them well. So that's going to be the reset, and that's the enable. Click, click. There we go. That piece is good to go. Side doesn't have anything connected to it. You could have done, or I could have done panel mount, USB and panel mount audio. I decided not to, and just have large enough holes that you can reach those two ports. Okay, I guess those will keep falling, so I'll leave that out. Oh, I gotta wake up this phone again. We have a picture of a mullet. Todd says, for labels, can you laser print some little transparent circles to fit in the arcade button tops? That is a good idea. If you take a look at these buttons, there we are. Thank you for pointing out that my audio died. The batteries went on my receiver pack. That should be wired, I know, but it's a battery-powered thing. Thank you, Andy and Mike P., for letting me know about the audio going away. Yeah, someone said about these buttons, you could stop them with some tabs. They don't go any further than this. Like the little flatted ends I put in mean they can't go further than that. So it's, I think, for simplicity, the way I'm building this, I can stop those without adding any tabs or anything, just by cutting that circle more precisely. That's going to bug me. There we go. All right. So next up, let's do the buttoning. Okay, so this is a two-part thing. So I decided, let me back out here for a moment and explain what's going on here. So when you do laser cut designs, you often use some sort of little slots and tabs to hold things together. So this type of thing here will be the width of this slot will be the same as the thickness of the material, and the height will also be the same generally, so it's the best fit it can be. I just don't like seeing that little square on the top, and I wanted to get slightly fancier, so I've built a double layered construction for the top, which means we fit like this, and then we have another one that goes on top that's only screwed down to the whole thing, but doesn't reveal that construction. So what that means is we're going to put all of those buttons and the joysticks through 2 layers. So I got to prep those. This is that hole I got wrong. I moved the circle in my CAD program right before laser cutting. I don't think this is textured. I think this is just white acrylic. Let's see. I think just based on that paper being brown on both sides, I think that means this is. But we're only seeing the edge of it. So this one's going to act just as a cool little color accent, like a little stripe on it. And the edge is always going to be shiny on acrylic. There's no getting around that because the textured surfacing is I think a treatment done to the acrylic. So this one, yeah, this is non-textured. I'm glad to see more textured acrylic in the Delvey store there, though. Todd says that I'm fancy. Thanks, Todd, with the double layered approach. Appreciate it. Yeah, you could kind of do that. It depends on your construction. You can kind of double up on this one, the base and the top, pretty well. Not the sides, just because I'm not using acrylic cement, or I'm avoiding it. But you could. The other thing I considered for this was, and actually Carlin Ma, our good friend, and very good friend of Todd, mentioned a guide to acrylic bending. But I didn't have time to build a little heating setup and do it and try it out. I've never done it before. But so that we were not going to see other than this little white edge here. And, oh, this still has paper. And it's funny, this one had clear plastic on the textured side and white paper on the shiny side, the gray. So they did it differently. Is this more talk about acrylic than you expected you'd be listening to today? It's more than I really expected to be saying, but I should have known. All right, so that's the top. Joystick on the left. Go like that. Nope. That. There we go. And so I'll start by putting buttons through, and I can then do the joystick as well. So these got to transfer over to here. We're going to go long because I'm just going to keep building until someone kicks me off. Unless Scott is going today, usually Scott is on Friday. Sometimes he does his show on a Thursday. I don't think that's happening this week. So unless someone else has got to use the Adafruit live stream, I'm going to stick around and finish this build. So the buttons here are fairly interchangeable other than the fact that I'm using my color coding ordering. So I kind of want to keep them as they are. That'll just make life easier. You can see that these are not meant to be changed very often. That's why I say some types of arcade buttons have like a little retaining clip and they just pop in and out. Not these. These ones have these collars that screw on, so you don't want to be doing this very often. I mentioned, I think I showed some picture of the earlier build of this and mentioned on Twitter that I had a lot of arcade buttons. And our good friend Thea Flowers said, I have gallons of arcade buttons. And that's because Thea makes that big honkin' button Eurorack module that has a arcade button in it. All right, so we're just going to shake off those into here. Just have a little, speaking of buckets. Okay. And I will just repeat this spacing or ordering over here. So, first button, like so. And to keep these held together, keep this plastic held together, I'm going to go ahead and screw this one down. This will be the third time I've put this together in one way or another, and there will be more by the time I'm done. Okay. Next one. So again, it's my yellow, red, green, blue ordering. And man, I wish I remembered. I guess I'll leave these a little loose so that I can reorient them based on this bend in the wire to get them as neatly plugged in as possible. And there's probably a way to hold this better than what I'm doing right here, but that's what we got. Okay, so those should stay together. I'll just go for it this way. Red, yellow, green, blue. It's not a disaster if you screw this up in one way or another, because you can just you can unplug and replug these whole cable assemblies, but I'd rather not. So someone say pizza? Did I say pizza? Andy's talking about pizza. Are you having pizza? I could go for some pizza. Okay, so that's 4. This is the second board. These arcade 1x4 stemma QT boards definitely make this wiring job a much easier proposition than without. So thanks, Lady Ada. I don't know what inspired this, if you had some arcade projects in mind, but does anyone know? Did Lamore say anything on a show about what gave her the impetus? I'd be curious. I was also thinking that this, I like the arcade theme here, so I don't want to really change it, but I was thinking it would be kind of fun to integrate one of these super huge mechanical key switches into this thing. One of these. Some kind of a panic button, maybe. Maybe that's the MIDI panic. Let's build that into the side of the thing so you can just slap the... I guess MIDI panic should be a E-stop. Big E-stop button. That would be a fun thing for Adafruit to carry, is a nice big E-stop button with a yellow casing, ruggedized, yellow mushroom switch. They're not cheap, though, generally. All right. Seagrover says he's looking forward to the time and a half coupon code because we've gone over. We're going long. Has anyone ever used one of those custom heat shrink tubing printers? Because then you can label, it's like a label maker for heat shrink tubing. You can label your, oh, one fell out. This one here. I think this project is okay with this level of organization, but some projects you want things to have nice names on them. You can read all over the cables. Code is buttons, 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 buttons. All right, we are almost there with these. All right, I am missing one of these screw collars, it seems. Hold on, there's one. And Yeah, that means we are done with this now. That can go away. That blue acrylic, by the way, if it looks familiar to you, I've used it in a few projects over the years. I originally got a couple huge, like 4-foot by 8-foot sheets of it for my Arduino Grande project. And I've been using it ever since, and somehow the plastic still peels off of it, which is amazing. Okay, so now we'll put the joystick in. So this just comes up through the bottom there. And since, again, actually this is kind of cool, since I'm using this double layer approach on the top, it allows me to countersink these screws. Not all of them, but these screws, if you look there, those can get countersunk. They're not fully flush, but close, which is neato for the joystick here. And let me grab some nuts for those. Also, these joysticks are built with some nice forgiving little slots instead of holes, which gives you some leeway. Like that. So let's get 4 of those nuts, 4 of those screws. And these are also M4, maybe, I don't know, 14 millimeter long, something like that. And for these, just to keep them from popping out, also, I like, with stuff like this, I like using hex head just because it looks a little neater than a Phillips screw, since it's exposed on the top. Why not look a little fancy, I say. Maybe for the Learn Guide, I will just point people at this video so I don't have to do too much photography. What do you think? I know the Ruiz brothers are very clever about pulling frames from video for Learn Guides sometimes. So there we go, get a nice clean installation there. I'll leave the screwing on of the joystick maybe as the final step. So now we've got these, zoom out, get to go into these. So yellow, red, green, blue, and I'll tighten up these collars afterwards. This is joystick over here. Actually, let's plug that in. Like that. Get that out of the way. And let's do bunch of plugging. Sometimes it's easier to go maybe from the middle out with stuff like this, just so you don't run out of space for your hands, but I think I'll try it this way just to keep some sanity. So again, the switch ones are the unmarked of the pair, and the LED ones are the marked, or color indicated. I love plugging modular stuff together. How fun is this? And that's one. Now, when I was first putting this together, I at this point would test this to make sure I didn't like really goof something up. Since this is the sort of third time I'm putting this together, I'm going to live dangerously and presume stuff will work and be a pain in the neck to troubleshoot if it doesn't. Todd says the problem with making things for publication is you got to build them like 3 times. Once to figure it out, once that actually works, and once to take the pictures during assembly. You want to know, I don't know if I've mentioned this before, kind of a neat trick, I don't know if it's a trick, but a neat method I've used before is to take photos of a disassembly. It's a lot easier to get that right. So once you've got it fully built, it doesn't work for everything, but a lot of times I will build a thing and then I will take photos of a step-by-step disassembly, which when you reverse the order, looks like assembly photos. Much neater. I've done that on video too, which if you can do like a time lapse and avoid making things look like there's no gravity by dropping them, don't drop things. No one knows. So, yellow. We are getting close, folks. I feel it. Red. Would it be nice if these were shorter wires? Maybe. It would be maybe a little hard to maneuver. Would it be nice if these were silicone wires? Sure. But overall, this is pretty manageable. Andy Calloway, I keep wanting to upload stuff to Instructables, but I keep putting it off. It's a lot of work, it's true. It can be. It's also gratifying, so try it if you haven't. And last one, it's this final button all the way over here is the first button on the fourth board, the other three being our little front panel function buttons. Oop, I got that wrong. So glad I bothered or took the time to color code stuff, because you can tell at a glance that all of the LED wires are actually in LED spots. Ordering looks right. Yellow, red, green, blue. Yellow, red, green, blue. That one fell. Yellow, red, green, blue. Red, green, blue. Okay. So at this point, I think I've got everything connected. I will do a little sort of dry fit assembly here. Maybe, yeah, this is just going to be a little bit of finessing things. I might screw down just a couple screws and then I'm going to turn it on and see if it's actually working. Again, if you're building something like this that's complicated and got a lot of wires with potential to touch other stuff, it's not a bad idea to do a continuity check with a multimeter to make sure you don't have ground and power touching. Get this clicked in here. I can't see those because I'm hiding them with my top thing. But okay, so that's three sides. Getting there. Let me zoom out a little bit, and this will be the not so fun one, which is lift that off. But acrylic is a little bit bendy. Not super bendy. It'll definitely crack if you're not careful, but bendy enough to do what I need it to do in this instance. Click. All right. Now, while some parts of this are together, I will drop in some corner screws here. And in fact, as I get one done, I will thread a nut on there to hold it together. You can see how dirty my fingers have gotten just from touching things that have touched the MDF, the singed edged, charred edged MDF. Okay, you need to pop in there. Let's get the other corner. One thing I may do on the final build of this, and then there's definitely no taking it apart backwards, is I may use some acrylic cement to connect these corners to each other so they're not flapping open, because you don't really get compression with acrylics. It's not like you can just screw this down tight and it'll force those edges together. Also, since these screws are a little longer by about 4 millimeters than I really want, I could do a thinner layer, like a 1/16 inch acrylic layer at the bottom, some spacer, just cut it on a grinder. There's some options there. Let's just put 2 more screws in, and then, actually, is that enough to hold? I think that's enough to hold to power it on, because if it doesn't turn on, then we will be taking it apart, so why make more work for us? Okay. Ooh, it's looking good, though. I'm happy with that. Okay, it's going to be very wobbly because we're on 2 screws. Let's fire it up and plug it into something to make some sound with. So first of all, I need a, what is this, a USB, a micro USB. I might just do a battery. Let's grab a little power brick battery. Oh, my phone just turned off again. Here we go. DB9 Dreamer said, that's what I was saying about 2 tabs per edge. It holds the corners better. Yeah, that's a good idea. I maybe do vertical tab, so that, because right now I just only have one in the middle. I think maybe that's what you're talking about. Yeah, a little bump there. Wouldn't need glue. So I think that's a good tip. Thank you. All right, let's see if this powers it on. So I've just got a USB power brick here. Plug that into my, so this is the feather. Let me show you this, if you can see it. The feather is directly in there. Like I said, I didn't use a panel mount USB, but I think I can get away with that without needing it. Okay, and then I will power this on. And my battery powered off. Here we go. Oh, it's not. I think this battery is not not happy. All right. Do I have a better battery option in here? I don't. All right. Let me get an actual USB power adapter. Here we go. This should be good. This is, I think, a 2 amp or 2.5 amp wall adapter. One of these days, I'm going to put some permanent USB ports, high power ones that don't turn off, somewhere. Either. So yeah, how are we doing on time? We're about 20 minutes over. Sorry about that. Okay. Power take 2. And I might need to be plugged into the computer. Sorry, yeah, I think I'm running USB MIDI. This might not turn on. I think it's going to hang. Yeah, I don't think that'll turn on until I plug into. Okay, let's plug it into the computer. Sorry about that. Let's move over here. Yeah. And all right, let's put a down shooter here for a second while I get this set up. All right, so I have my little curly cables. boop. Sorry about that. All right, give me a moment. I'll focus that. There we go, shiny buttons. Okay. Is this upside down? It is. I wish this were USB-C, but Feather M4 is not. Okay.
I see a light. I see
the red LED. Let's hit reset. Okay, you can see I'm already going to regret not having an easy way of lifting the top on this. Darn it. Let me... I don't think I want to mess with... Let me just make sure my serial port is closed on this. It is. Nope. Go towards the light.
Okay, that's off. That's on. That's reset.
Those LEDs are not coming on. All right, let's crack it open. Yeah, I doomed myself by saying I should be fine. What's that extra wire for, someone said? I don't know. Okay. So what? Okay, so you can see here, let me switch this to a bigger, you can see that there's power going to all of the, these little I2C boards. For the buttons, they have green LEDs under them that light when they get power. You can see over here, my feather is lit to say that it's on. Is there a chance that I got these two buttons plugged in wrong? In which case, it's never going to be fully on. Let me unplug those. Okay. Let's, I'm going to open up Arduino. And I will re-upload the code to it just in case something funny went on there. But I don't see any missing wiring. And I think that's always the port I was going into on I2C, yeah. All right, let me reopen. Sorry, you won't see this, but I'm just gonna reopen the code that should be running on here. Sure, this one should do it. All right. And in Arduino, I'm just going to check that the board is available to flash. And so right now I'm letting Arduino compile the code, which it takes longer the first time after you open it. And once it compiles most of the way, I will double-click the reset button on the feather, which puts it into bootloader mode and should make it appear. Okay, so, oh, see, I'm not seeing it pulse. There's a pulse that it is not doing. All right, let's see if it gets found. So I'm watching it try to find an available port, and it's not finding it. Something is bad. What is it? I'm just going to try to unplug power. So it should fail to launch if I can get the code onto it, because I've unplugged the I2C. Funny thing is, very little has changed about this side of the hardware since last week, or the demo I did the other night. So this was supposed to just be the enclosure build today. I wasn't anticipating this. Let me just try a different USB cable. Ah, that's a good sign. All right, you know what I'm going to do is I'm going to replug the stemma QT boards into here. And let's see if it just comes to life. I'm also going to open up a MIDI monitor to see if it'll find the device. Okay, so it's seeing it, but it's not receiving any button presses. So it knows that the board is there, which is good. I'm gonna yeah, this is enable. So I'm gonna replug in my little hardware reset and hardware power. I will unplug this first. And I do see now the mark that I had put on those, so that's good. This also means I know those should be good. Okay. But those don't need to be plugged in. Those were optional, so I don't feel like those should have. Yeah, so the way I know that it's kind of not working is I'm never seeing these light up. You know what? One other thing I'll do, let me open up the serial monitor in Arduino. I turned off any wait for serial lines of code in there, so that shouldn't be it. But I've seen weirder. Okay, look, there we go. Let me share this screen with you, actually. Let's do a screen capture, new screen capture. 1 second. You're going to get a funny mirror effect for a second, but I'm just going to pick one window, which will be this serial monitor. Okay, so this is some useful feedback from Arduino. It is saying that it's launching the serial and MIDI, which makes sense. That's why I'm seeing MIDI show up. But it isn't finding the I2C devices, which it's too bad those light up green, because that just probably means they have power. But that means something is wrong. And what I'm going to try is get that longer cable back and go to the far side of this board in case, I kind of had this nagging suspicion earlier that that was a that was a possibility, that either this cable or this little adapter that I'm using, you can't quite see it, was an issue. So let me just make a little space for myself. We'll try to plug in, like remember I said it's hard to plug these in underneath there when it's in place. I may need some needle nose pliers. In fact, I'm sure I do. Right angle ones would be great, but I don't think I have any right here. Let's see if these are thin enough. Otherwise, we can, let me get this out of the way, unscrew that and get in there. Okay. And now, first of all, I'll just run this where I had it there, because I think this is I think that board breaks them out on both sides. But in case it doesn't, I will go to the other side of it. So I don't know if we'll see that serial message update itself. LED arcade not found. Okay, so let's pop over to the other side. Whoops, sorry. I should unplug that. I don't think I had it over there, but it's a very inconvenient spot, in fact. And if not that, what? I don't think I had it over here. There's also a chance, I didn't really deal with these that much. There's a chance I damaged some bit of wiring on my little proto board there. All right, so let's go over to this other side. I don't think I had it there. Weirder things have happened, sure. Yeah, LED arcade not found. Why? All right, I think we're gonna have to call it there. It's a mystery. I will, I'll get this fixed the rest of the day. I'm sorry I can't do it on screen for you, but I don't want to keep you any longer than this. I don't want to get into a marathon. But other than it not at all working, it's a pretty cool build. Hope you like the actual physical enclosure design side of it. And I will get this up and running. I'll let you know what went wrong with it, and then I'll put together a learn guide so that you can build your own. I think that's going to do it. Thank you everyone for stopping by over in the Discord and on YouTube. For Adafruit Industries, I'm John Park. This has been John Park's very extended workshop. Bye-bye.